Hello everyone and welcome to our tech session for today. I know there are a few familiar faces that were just with us in our previous discussion. Today we are unpacking static and dynamic models, and Ramsey is leading our discussion and demo walkthrough. So a few weeks ago, we went through a credit card kind of activation use case and how you would figure it as a project on the workbench. And through that discussion, we looked at different cases of where you would use, a static model or a dynamic model. So the aim of today's session is to just unpack it a little bit further, unpack the reasoning as to why you would pick different models given, your use cases and approaches. I'm going to hand over to Ramsey and he's going to take it away today. Thank you.
Thank you, Madison. Before we can I see that we have a hand raised. Sai.
He should be able to participate in a second.
Yes. I have made them a contributor. Maybe just pop your question in the chat for the meantime. Okay, cool. Ramsey, I think just continue.
Oh, wait, there it goes. Okay. You guys see my screen share? Okay, cool. So I'm just going to do a brief talk about what are static and dynamic models and how to kind of consider them in comparison to each other. What's important to understand is with any of these things is it's not a one-size-fits-all thing. Sometimes you want to use dynamic models, sometimes you want to use static models. And I'll just take you through a quick demonstration of how you would go about setting that up in the ecosystem environment. First off, the most basic thing we probably just need to understand is what are we talking about when we're talking about recommendation models? Most of you are familiar with them, but for those who are not as familiar, it's kind of define a definition so we know we're talking about the same thing. Essentially, recommenders are just a way of adding kind of intelligence to your company, to your data flow, to your customer journey, whatever. So you can use it to recommend pretty much anything that a customer would see, whether that is a product, a message, design element, special offers. There's a bunch of ways you can interact with your customer and make sure you're giving them the best experience or the best recommendations. At any point that you are in a customer's journey and there's some kind of choice as to what to show a customer, you can insert intelligence in there. So kind of before recommenders, those are usually these static things where you would say like this is the best image to show them, or this is the best message, or this is the best order to place the elements in your web app or on your web page. But now we have AI technology set up to enrich and enhance these experiences and to make them more personalized, more aware of how the customers are using them. But first of all, let's look a bit at some static models. These are usually the ones that most people are familiar with when you are first dabbling in the space. These are the big models that you are training large amounts of data. Obviously, depending on the scope and the scale, training times can vary from a few minutes to hours to days to weeks. You need to consider things like GPTs, those corpuses take months to train. So that is important to keep in mind. Another key feature of static models is that because you are taking a snapshot of history at one single point, you're saying, this is all of the data I have at point X. Let's make inferences from this historical data and say that the future is going to look similar to the past. Just a list of type of models that you would use in the kind of static modeling environment. Most of you guys will be familiar with. You have AutoML, which is just your shotgun approach to doing it, where you're saying, let's just throw a bunch of different models at them and see which one performs best. Then you can have your standard gradient boosting machine type models, do stuff like XGBoost and whatnot. Now, then you have your deep learning models, which just a bit more complex. Then you get your kind of more specific type of models where you want to do like anomaly detection. You can use like your isolation for stuff, or you want to find out categorization type models, and you can cluster things together. You can use k-means, and if you want to get really simplistic, you can use linear regression models, just kind of statistical methods of just finding trends in data. So in comparison to that, looking at static models, how does dynamic models look differently in them? So dynamic models usually use real-time feedback. And what's important to note here is by feedback we mean, so static models also have real-time scoring, or it depends on how you set your thing up. You can also use batch scoring. But in our environment, we usually prefer to do real-time scoring. But the key differentiator in dynamic models is the real-time feedback. So the ability to immediately see what customers are doing and how they're reacting to the recommendations that you're making to them. This basically means that every time a customer scores or a customer accepts anything, that all those information is logged and pushed back into the model to retrain it instantaneously. So you get the latest data, the latest information about your customer and their trends. Another key important factor about this is that because you are kind of using this iterative process to training the model, you don't need any data at the start. So essentially you can do like a cold start where you have no data, but true that is going to be horribly bad in the beginning because it's essentially just going to guess a recommendation. But as soon as it's going to start seeing that, oh, I gave it recommendation A, nobody is interested in it, it's going to start weighing that option lower and lower until it gets either completely removed, or you'll find maybe at some point later in the year where buying patterns or behavior patterns are different, that offer might become interesting again. So that just means that the whole system is very experimentation based. So it's giving recommendations, seeing how the customer is reacting to it, and then adjusting appropriately. So in our current system, we have kind of 4 main algorithms that do this kind of dynamic modeling at the moment. So we have the epsilon greedy, which is kind of the simplest, the most straightforward one of these. Essentially, what you're just doing is saying, you know, from what we've seen before, just give the best answer or the one that people like the most, but at specific times, depending on the epsilon setting that you set, just give a random answer instead. This is just to ensure that you are not getting stuck in local optimums. So you might see that if you are giving people option A, that 60% of people like option A, depending on how you split out your clustering. So depending on how you look at the individual level or specific groupings of customers, you'll give random answers. That random answer is important because you want to be able to break out of those local optimums. At a certain point, one answer looks good, but later another answer might be better, or the first one you found was a good answer, but not the best answer. So you just need a bit of randomness in there to make sure that you're shaking the packet loose and all the crumbs are dropping to the right place in the model you have. Next, we have the ecosystem rewards model. So it's essentially kind of Thompson sampling, but just some extra secret sauce on there. Essentially what this is doing is creating a beta distribution. So just like creating a graph, a bell curve for each option, and randomly sampling from the bell curve to give a score for each option in your recommender. But obviously in the beginning, when you have no data, that's just going to essentially give you a random answer. But as you get feedback from both the scores that was given and not taken up and the scores were given and taken up, it's going to affect the shape of that bell curve. And then as the sampling starts happening from the bell curve, you're going to see the more important or more taken up recommendations are going to get shown to the customer more and more. What's nice about this one is it's kind of the default one now. So in most cases used in the beginning, before you want to get more deeply into the use case and what's important to do there. There's a nice balance between how well it learns and how explainable the answers are. You can see at any given point how the model has been trained and why it is getting the answer that is currently given. Compared to the other, it has a lot more options in setting up historical data, so that you can do dynamic models. You can just put in historical data in the same way that you would in real time, but do it as a batch. And next up, we have the Bayesian probabilistic models. Kind of uses the naive Bayes structure or modeling algorithm. So where it's looking for. And this is the best one if you want to make sure you are getting the best answers as accurately as possible. But it is very obtuse in understanding why it's giving the answers that it is. It's important to remember what your business case is and what you actually want to solve. And then we have the Q-learning, which is the most complex. The reason for that is primarily because you have to add in custom code because you're setting up reward lists, and those lists have to be encoded into the system. Currently, we require you to use our post-score functionality, which allows you to inject custom code into your recommendation pipeline to set up the Q-learning facets. It's more configurable, but you have to go configure it. Okay, let's have a quick question here. I have a working prod DB full of live data of bank transactions for clients. How would you run a static model on the data in a way that wouldn't cause any sort of compute errors on the DB or processing limitations? If I understand your question correctly, Ryan, when you are building a static model, you usually use some kind of modeling environment, whether it's H2O or PyTorch or TensorFlow. And to be able to actually use the data, you have to encode it into a training frame for whatever platform you're using. So at that process, you just need to pull the data at some point and then run it on the modeling platform. So you don't directly connect to the prod DB. You essentially just make a clone of the data that you're interested in with all the feature engineering and things you've done on it. It won't take a lot more power than just full data pull. Depending on the size, it might have an impact, but it's as little impact as you can have on a database. And then you'll need to have separate then compute power for the model training. So ideally, they wouldn't sit in the same system. But if you have a virtualized environment like Kubernetes, then they will essentially be on the same system, but in their own kind of privatized clusters and whatnot. It seems like Ryan is happy with that answer. And then just to give you a brief overview of what we just talked about, the static versus dynamic, just to keep in mind what are the big differences between them.
Ramsey,
So,
just before you, there's one quick comment, is that
yeah.
the behavioral models, there's also a class of the behavioral models that might want to cover separately at some point. Yeah, because we got the generative, the loss aversion, sentimental equilibrium, prospect theory, and a couple others that are behaviorally oriented, that has got flavors of some kind of probabilistic prior-based approach. But that's not for today. It's fine.
That's
I'll mention it when we have it in the outline.
Essentially. So then to condense the differences between the dynamic and static models, just make a quick key feature list between the two. So yeah, so static, you always require historical training data. You usually need a lot of training data depending on the complexity of your use case. But for a very simple case, it simple means how easy the behavior is to predict that you want to make recommendations for, and how dimensionally big the environment of your data is. If you have a category like, are you married or singles, that dimension is just 2 spaces. But if you have another field that is your age, and that dimension, depending on if you break it down into different categories, can be anything from 0 to 100. So that's going to be at least 100 different answers in there. So each of your fields brings extra depth of dimensionality. So depending on how much data and how much different features you want to import into your data set, the training data will need to be large, take into account all the different permutations of what the history looks like. Where the dynamic, like we talked before, is because it doesn't care about the dimensionality of the data, it just looks at how people are interacting with the system. You don't need any data. You can just go from nothing and train your model, train your model on the fly. Yeah, another important difference here is that because you have this periodic training of the model, and this is going to be a function of how long the model takes to train and how much compute power you have to retrain the model and availability and things like that. Your model is always going to be outdated. The moment you finish training your static model, it's outdated. Because new information is coming in and you don't know how that's going to affect anything. Where your dynamic model is, every interaction is immediately logged and used to retrain the model. So it's always as the latest up-to-date information. Depending on how you set your forgettability factors, you can change how much weight the new information has versus the older data. I also mentioned the retraining thing, because the function of the data I just shared with you makes dynamic models very good at finding new trends. So if you have something weird happening on a day, let's say like a World Cup is happening on a particular day, or some presidential election, or another kind of very seldom seen event that happens once a day, or we have confluences of factors of weather and things happening, your dynamic model will be able to pick up the changes in customer behavior very quickly because it does retrain dynamically on interaction. So if you see, because of extraneous events, something weird is happening on a day, your dynamic model will immediately pick that up and go, okay, people for now want to buy product A instead of product. But the static model, unless you somehow train that model in the middle of the day, it's just going to think that nothing new is happening. I just know what happened in the past. So it's just going to keep on giving you answers or recommendations based on what's happened in the past and not in the future, or not in the present. Yeah, and just kind of a more kind of philosophical difference between the two is that the static model is more evidence-based. So it looks at what has happened and says, this is what the answer is, where your dynamic model goes more like, I'm just going to give you answers and see what you like. So that's kind of the key philosophical differences between the two. And the static model, just also due to a function of how it functions, is that the static model is, the moment you finish training it, it's accurate. Or as accurate as your data allows it to be. Where model, given that you have a cold start and how you set your convergence matrix, hyperparameters rather, will take some time to get to a good answer. That can be anything from a few hours to a few days, depending on how quickly the traffic is between your customer and your interface. Those are kind of the key differences that I think is the most important for you to know. Obviously, there's a lot of technical differences as well. I don't know if anybody has any questions at this point. Anything that's not clear or that I went too fast over?
There's nothing in the chat so far. Please, anyone feel free to raise your hand or drop a question in the chat.
Cool. Well, now that we all know kind of the differences, let's take a look at how we can actually implement this on the system. So wait, I'm gonna do that. Let's make all this and go in here. I see Ryan S has his hand raised.
Ramsey, super interesting so far, man. Out of curiosity, from your experience, which is more maintenance to upkeep? The static or dynamic?
Well, it's definitely the static in the sense that you have to, if you want to put it in production, you have to have a lot of pipelining things in place to redeploy it and retrain it at whatever period you require. So whether it's weekly, daily, or monthly. Because you have all this historic data and you have to do all of this feature enriching and engineering to get it set up. That's a bit more about how costly it is to set it up in the first place. But once it's trained, now you have a static model that has a certain opinion about things. But you might want to now in the future make some changes to it because you realize that this particular feature is not as useful, or you want to enlarge your option store, like have more products to offer. And now you have to do all of the model comparisons, do all the testing, all the feature engineering again, just to make sure that you have the right tool for the solution. We have a dynamic model, like you've got a few options, and there's some parameters you can tweak on the fly. You can change this parameter to X now to see how it performs and track it over time and then change it later again. So it's definitely, in my experience, a lot easier to maintain the dynamic models in our environment, at least. The static models due to the overhead of actually setting up a new static model. So obviously that also depends a lot on what static model types you use and what platforms you use. But in general, I would say that the dynamic models are easier to maintain, with the caveat that due to the nature of it being more ephemeral and experimental based, and that you have that kind of quick turnaround time, you usually won't have as complex business cases. You have a very large, complex static model problem. It's going to be very hard to translate that into a dynamic model due to the complexity and scale. If you have incredibly large dimensionality in your problem statement, it's going to be almost impossible to do that in a dynamic fashion. It's just computationally too costly to do it, like every iteration to retrain the model. So in that case, it's like so I would say if you can use a dynamic model, if you can't use a static model, that's usually my go-to.
Got you. Amazing. Thanks, man.
Yeah, cool. Yeah. So I'm not going to get too much into the platform, as we're just going to be explaining the specifics around it and the static models in our environment. This is our ecosystem workbench. We're going to be looking at these two sections up here, the static and dynamic models. You come in here first, you can set up our feature stores. I'm not going to get too much into that because I think we have covered it a bit in our previous sessions. But you'll basically be setting up your feature store, setting up all the data and preparing the data to be used by a model. Cool. And you get to your modeling section here. So most of these are just for internal use. Give a name to this. I'm just going to call it demo. Allocate it to a project. I'm not going to do that for now. It's called demo. The important type here is going to be a model type. You can see some of the ones I mentioned in here. Jay also mentioned some of our more behavioral-based models. Depending on which one you use, it's going to affect how you have to set up the parameters for the different model type. Let's take the AutoML. It's a fun one, and it uses a lot of the underlying model as well, since this is a shortcut approach. We can just call this category demo as well. And we have to use our primary data frame. From the feature store, we set up our data. I'm just going to pick a random one here. Then enrich, give it a feature. Now we have that, we need to set up the hyperparameters for this model. So depending on the model type that you choose, this generate default button will set up all the hyperparameters that you would be generally interested in. Some of them aren't in here, but you can look at the H2O documentation if you're really interested in adding the more specific ones. But 99% of the time, the parameters are going to solve all the problems that you have. You basically set your training and validation frame and your response column, which is just what the prediction is going to be, like whether it's a yes or a no or some percentage or a number based on all the other data given to it. And then you set up more parameters around how long and how hard you want this thing to train. This is how many models you want to train, what the stopping tolerance as well, what the runtime is, how many rounds, whether it should balance classes, whether it should, what the stopping metrics should be, all of those things. The more important ones are going to be this exclude algos. And so these are the 6 algorithms that we do that the H2O supports for the AutoML, and you can just turn any of them off that you want. In this case, there's an include and an exclude algos feature. We just like to use the exclude one. It's more like a whitelisting. You just say that I want to use deep learning and delete that out of there. Now this is going to be training on nothing but the deep learning. And so depending on what you think is required for your thing, you can set it up to use particular cases. If you know for certain that you just want to use a particular model type, you can just pick that one. And then once you have all your information set up, you just click this generate model button. That's going to kick off all this configuration data we set up for the model training to the target platform, whether that is H2O or TensorFlow or PyTorch. It's going to send it to the server that monitors and runs the training. You can then periodically check in on the progress by clicking this result button. It'll show you all the models that have already been trained. The other one, we're just going to train usually just one model. We'll show you the results, and you can then go and inspect those models. So just look at some existing models that we can expect. Here's a GBN model. You can come in here and look at it. You can see the training metrics versus the validation metrics. It looks like this one used the same data for the training and the validation set, which is usually a bit of a cheat. Gives you some information around the different domains of the, geez, this is a very big MCC category. It's a very big domain. Some using here. It gives you some information on variable importance. This is a nice cyclical process where you can see some category has too much importance. Usually if that's the case, it means it's something directly correlatable with the output that you're trying to predict. Something like the case of, let's say you have a field, or you want to predict the field of, is a sale going to be made? And you have another field that tracks whether or not a person, what would be a good example, whether or not a person called the sales center. People who actively call the sales center usually want to make a sale, as opposed to you doing outbound messaging. Then you have a lot smaller turnup rate. So like it's good to find those kind of things. And also the flip side, if you have fields that have like almost no variable importance, there's no point adding it to model. It's just adding unnecessary complexity to the modeling, and you can remove it, and it will usually increase your training time quite a bit. Yeah, and then you can kind of just check all the model analysis you have around there, your confusion matrices, your variable validation log loss, things like that. It's a nice way to check all of these things. This is going to vary quite a bit depending on the different model types. You can see there's a bunch of different ones in there. So that's pretty much it for the static models. The majority of the knowledge is going to be specific to the modeling platform and modeling type you're using. And we are just a supporter of or environment in which to use these models. So we don't maintain the different models. If you want to understand how to use them more effectively, just go to the particular specific documentation for those different types. Then we get to our dynamic models. Here, let's create a new one. So similarly, another one, we're going to give the name to this, some information to it. Then we give it a feature store. So this is not going to be a historical data feature store. This is just going to be a domain space feature store. Basically, it's going to tell the model what is the information that you want to predict. It's essentially going to look a bit like an option store. It's just going to have all the products, offers, or recommendations that you want in there, depending on the dimensionality you're interested in. If you want to group the customers in certain ways, you just have to add those different fields or dimensions in there. Actually, just pick those ones. Let's just pick a random field in here. It's not going to be that important. And then you have your option store. This is where the actual information that's going to be saved for the retraining of the model. It auto-populates whatever you filled in there for options, but you can name this whatever you want. And that's going to be a first step. And you're going to come to engagement. And here is you're going to kind of pick your different models. Like I said, we're not looking at the network and the behavioral stuff. It's just the straightforward dynamic. This is the kind I mentioned before. You can pick whichever one you want. And they're going to have different setups you can do. Some of them we have wizard setup. You can go through to kind of explain the information in a bit more straightforward way. But in this case, I'm just going to quickly take you through this one we're using now as the ecosystem rewards. This is based on Thompson sampling. And there's some few features or parameters you can set here. They can set up the cache duration. This is for if you are recommending a product, recommending something to a customer, it can sometimes be jarring depending on the use case if it changes too rapidly. So let's say you have a recommender that changes the color of your website or the color of the banner. Every time the customer refreshes it, the color changes because it doesn't have enough information yet to give a consistent answer. That might be quite jarring to a customer and things like something doesn't look right. So you can then set up a cache duration for when the model hasn't converged yet, just to ensure that the offer that was made to a particular customer is going to remain static for a certain period of time. So this customer was given this recommendation an hour ago. The cache duration is longer than an hour, so just give them the same one you get before if that call happens again. Then we have our processing window, which is just how long you want to consider your historical data. If you set it for 10 days, it's not going to take into account any data that's older than 10 days. Similarly, you can, instead of using a time-based window, you can use an interaction-based window. So you can just say, look at the last 1,000 cases or 100,000 cases, depending on whatever the scale of your system looks like. You can also set up calendars here. This is going to behave differently on specific calendar patterns. So whether you want it to behave differently on the weekend or on public holidays or differently on month ends, things like this, you can set up in there. Then we have the decay parameter. This is if a customer is like spamming a recommendation. Once again, it depends on the use case, whether this is going to be sensibly possible or not. It's just going to lessen the effects of the retraining. So let's say like I said, once again, it's going to be a color of a browser widget. A customer might be refreshing that page 100 times for some random reason. You don't want all of those to be as powerful as a person who just came to the website once and then did something. So you can add a repeat delay or a repeat decay on it. Where you have a case like you are sending outbound messaging, the customer doesn't have a real way of requesting another message. They can just like ignore the message or buy whatever product you're offering them. Then you don't really need decay for that. And the same way with our max interaction count, it does the same thing. Instead of having a decay, it looks at if you start interacting too many times, it's going to start ignoring any follow-up interactions in a certain time period. So if you are spamming this thing again, instead of decaying it gradually, it's just going to stop it completely. And then you have your convergence parameters. So this is where you're going to look at how valuable your successes are versus your failures. This is also a function of how you see customers interacting with your system. If you know they can get a lot of scores for a single acceptance versus a single score for a single acceptance, you need to adjust these values. But you're basically just going to balance these values out. You can say that if you think that the amount of successes that you require for a single failure is going to be 1-to-1, so you can just make this 1-1. So it's almost like a ratio, but this is not always going to be 100% true. So you can just kind of play with these values a bit until you see optimal convergence happening. And the prior success, prior failure rewards is just another way of decaying the values a bit. If you're getting multiple successes from the same source, don't weigh them as heavily. Right? And to keep in mind, this is going to be the same as making this then. This is a function of the sampling algorithm, which does the beta distribution graphs that I talked about earlier. So it's all just going to plug into that. But in most cases, well, not in most cases, but for the main, what's the right word? Predominantly, these are going to be kind of similar, just because it's mostly just a ratio of each other. Then you get to your variables. This is now going to be the data read from this feature storage you set up over here. Don't even know what I just set up there. So it just shows me all the offer keys that I have here. So I say my offer is going to be this. Does it have any values in there? It either has a lot of values or, oh wait, there's only offer ID in here. Don't know what this table is that I just generated. Let's see if I can find something a bit better. Just find something that's a bit more usable. Maybe banking agent. The product offers might be useful. Offering a savings, loan, credit, or mortgage product for a bank. Because you have one offer now, you could add in if there was a customer ID in this table. If you wanted to do it on an individual level, you could add the tracking key in here. If you want to look at individual instead of as a grouping. And here you can also set up a take-up. This is where you want to inject your historical data. If you have a field that has some weight to the data, then you can add in a historical take-up rates here. And you can additionally also add in your contextual values. So this is going to be a way of increasing the dimensionality of the grouping. So like I mentioned before, in that training set, you can set up multiple different features or fields that you want to potentially group your customers by. You just fill in your fields in here and add them. It's a bit more complexity to this because if you do get, so in most cases, you're not going to use that many contextual variables for this. But if you do have some cases that you want to use a bit more, there we have a functionality in our deployments page where you can essentially merge fields together, concatenate them, even dynamically. You don't have to do that manually. But it takes all of your different fields that you want to merge, and then you can just select the one dynamic feature in here that will group all of those things for you correctly. And then once you're done, you can click this generate button. This is a nonsense example I just made here, so I'm just going to take an existing one. This one does not have an option one, so this one was not used before. Let's look at this one. Yeah, you have something like this. This one hasn't been trained yet. Let's find one that has been trained. This one might be. A little bit trained, but not very well. In this case, we now have an option store. It just shows us some of the values that have changed over time. In this case, it looks like people have not selected any of this because the alphas haven't been updated. These values have changed. And then there's also some, where's the graph? This thing doesn't have any good graphs. I want to get a better example. Let's see here. Maybe this one. Okay, this one looks good. Let's see. So it's not displaying it very nice. Now, it's just like some easy graphing for you to be able to see if I can change this to make it a bit more readable. No, that's making it even worse. Let's do it on the betas. There's just some graphing that you can see the relationships between your different options and different clustering that you've set up to them. Depending on the case you have, this will be easier to read than some others. These are quite chunky outputs in here. And that is pretty much how you will set up the different dynamic and static models. I'm not sure if I should delve into how you prefer to deploy them, but because we have touched on that in other cases. Once again, I took you over the main patterns here. Like I said, there are a lot of different ways of working with this at different cases, different stuff you can set up. And I think now you should have good overview of how you would go about setting up static and dynamic models in our platform. But I think that's it for me.
Thank you. Thank you so much. I really enjoyed that you gave us the context first, and then we got the demo walkthrough of how you would do it. I think
Yeah, no,
that really
otherwise it
helped.
would be very hard to do.
Yes.
Understand what's going on.
On that, do we have any final questions? There are no comments in the chat, but if anyone would like to raise their hand or ask anything, now's the time. Otherwise, have a wonderful evening. We will have our next session. We are looking at generative models, and Jay is leading that discussion.